December 17th, 1942. The desert heat still shimmers above the scorched battlefield near Teburba, Tunisia. Smoke drifts lazily from the twisted wreckage of Allied armor scattered across the sand like broken toys. Field Marshal Erwin Rommel's Afrika Korps has claimed another tactical victory, pushing back British and American forces with a methodical precision that has made the Desert Fox a legend. But in the aftermath of this triumph, something waits in the sand that will challenge everything the German military believes about modern warfare. Obergefreiter Klaus Weber picks his way through the debris field, his boots crunching on spent shell casings and shattered glass. The acrid smell of burning fuel mingles with the metallic tang of blood and cordite. Weber has seen dozens of battlefields like the German testament of this one, each tactical superiority and Allied material waste. Destroyed Sherman tanks sit like monuments to American industrial excess, their thick armor plates no match for German anti-tank guns. British carriers lie upended, their tracks blown apart by precisely placed explosives. But something catches Weber's attention among the wreckage. A small, angular vehicle sits intact beneath a camouflage net, its olive drab paint barely scratched despite the violence that has swept across this ground. The vehicle is tiny compared to the massive tanks surrounding it, almost insignificant. It looks more like a civilian automobile than military equipment, with its simple rectangular body and exposed spare tire mounted on the back. Weber approaches cautiously, expecting to find another piece of Allied junk abandoned in retreat. The vehicle bears American markings and a serial number stamped into its frame. Weber has never seen anything quite like it. German military vehicles are purpose-built machines, engineered for specific roles with Prussian attention to detail. Half-tracks for infantry transport, armored cars for reconnaissance, staff cars for officers. Each vehicle represents a carefully calculated solution to a particular military. This requirement American machine defies such categorization. It appears almost primitive, like something a farmer might use to haul supplies across rough fields. Weber climbs into the driver's seat and examines the interior with growing curiosity. The dashboard is Spartan, featuring only essential gauges and controls. No luxury appointments, no unnecessary complexity. The seats are canvas stretched over simple metal frames. Everything about the vehicle speaks of utilitarian purpose, stripped to its absolute essence. Weber turns the ignition key, expecting nothing from an abandoned vehicle that has endured hours of bombardment and desert heat. The engine fires immediately with a steady, confident rumble that surprises him. No hesitation, no rough idle, no mechanical complaints. The small four-cylinder engine settles into a smooth rhythm that suggests it could run indefinitely without attention. Weber engages the clutch and shifts into first gear, feeling the transmission respond with mechanical precision. The vehicle moves forward smoothly, its suspension absorbing the uneven ground with surprising effectiveness. Within minutes, Weber is driving across terrain that would challenge far heavier German vehicles. The little American machine climbs rocky outcroppings without difficulty, its four-wheel drive system pulling it up slopes that would stop conventional automobiles. In deep sand that bogs down trucks and staff cars, the vehicle maintains forward momentum with seemingly effortless traction. Weber realizes he is witnessing something unprecedented in his military experience. The vehicle handles like a mountain goat, nimble and sure-footed across terrain that defeats much larger machines. Weber drives it through a dry riverbed filled with loose rocks, up a steep embankment, and across a field of soft sand that would trap most vehicles. Each challenge is met with the same steady competence. The engine never overheats despite the desert conditions. The transmission never balks at the demanding terrain. The suspension never bottoms out or loses control. By the time Weber returns to the German lines, word of his discovery has already spread. Officers gather around the captured vehicle, examining its construction with professional interest and growing amazement. Major Wilhelm Hoffmann of the Heereswaffenamt arrives within days to conduct a preliminary assessment. What he finds contradicts every assumption about American military engineering that has guided German strategic thinking. The vehicle is designated as a Willys MB, manufactured by the Willys Overland Motor Company in Toledo, Ohio. American soldiers call it a Jeep, apparently derived from the military designation General Purpose Vehicle, EVRY. Hoffman documents aspects of its construction, measuring dimensions, photographing components, and recording technical specifications that will later prove crucial to German understanding of American industrial capability. The frame consists of simple channel steel welded into a ladder configuration. No complex curves, no sophisticated engineering solutions, no evidence of the precision manufacturing that characterizes German military equipment. The body panels are stamped steel formed in basic shapes that any competent metalworking facility could reproduce. The suspension employs leaf springs and solid axles, technology that German engineers would consider outdated for military applications. Yet the vehicle works with a reliability that impresses even skeptical German observers. Hoffman orders extended testing under conditions designed to reveal weaknesses and limitations. The Jeep endures every trial without mechanical failure. Sand enters the air intake during desert operations, but the engine continues running. Oil levels drop below recommended minimums during extended trials, but no damage occurs. Cooling system temperatures exceed normal operating ranges during sustained high-speed runs, but the engine maintains power without overheating. The vehicle's capabilities extend far beyond simple transportation. German observers document its use as a weapons platform, ammunition carrier, communication vehicle, and medical transport. American units routinely tow artillery pieces weighing several times the Jeep's own weight across terrain that would challenge tracked vehicles. The little machine serves as a universal solution to military mobility problems that German doctrine addresses through multiple specialized vehicles. Within weeks, the captured Jeep is loaded aboard a transport aircraft bound for Germany. The High Command has ordered comprehensive evaluation at the Kummersdorf Proving Ground, the same facility where captured Soviet T-34 tanks underwent examination that revolutionized German tank design. The American vehicle joins a collection of enemy equipment that includes British Churchill tanks, Soviet artillery pieces, and captured aircraft from multiple Allied nations. The journey from Tunisia to Germany transforms the Jeep from battlefield curiosity to strategic intelligence asset. Senior German officers recognize that understanding American military equipment provides insights into American military thinking and industrial capability. The vehicle represents more than engineering solutions to transportation problems. It embodies an entirely different philosophy of military logistics and battlefield mobility. At Kummersdorf, Major Hoffman assembles a team of Germany's most experienced automotive engineers and military specialists. Franz Müller brings expertise in transmission design from his work with Mercedes-Benz military contracts. Dr. Hans Zimmermann contributes knowledge of engine technology developed for Luftwaffe aircraft applications. Together, they will conduct the most comprehensive examination of enemy equipment undertaken by German technical intelligence during the entire war. The testing facility at Kummersdorf represents the pinnacle of German military engineering capability. Precision instruments measure every aspect of vehicle performance with scientific rigor. Dynamometers record power output across engine speed ranges. Specialized equipment evaluates suspension characteristics under varying load conditions. Environmental chambers simulate extreme temperature and humidity conditions found in different combat theaters. German engineers approach the examination with professional curiosity mixed with institutional skepticism. American military equipment has consistently disappointed German expectations, appearing crude and unsophisticated compared to German engineering standards. The Sherman tank, though numerically superior, lacks the armor protection and firepower of German designs. American aircraft, while produced in vast quantities, rarely match the performance characteristics of Luftwaffe fighters and bombers. But the Jeep presents a puzzle that challenges German preconceptions about American engineering capability. Initial measurements reveal construction techniques that violate established principles of precision manufacturing. Tolerances exceed German standards by significant margins. Surface finishes appear rough compared to German automotive components. Material selection emphasizes availability and cost over theoretical performance optimization. Yet comprehensive testing reveals performance characteristics that exceed German expectations across multiple categories. Cross-country mobility surpasses comparable German vehicles despite the Jeep's smaller size and lighter weight. Reliability measurements document operational endurance that German vehicles achieve only through constant maintenance and adjustment. The American machine simply works under conditions that would disable more sophisticated German equipment. The implications become clear as testing progresses through the winter and spring of 1943. German engineers are witnessing industrial design philosophy that prioritizes practical effectiveness over theoretical optimization. American manufacturers have created a vehicle that sacrifices precision for reliability, sophistication for simplicity, and individual performance for mass production capability. This revelation carries profound strategic implications that extend far beyond automotive engineering. If American industry can produce reliable military equipment using simplified manufacturing processes and readily available materials, then American productive capacity exceeds German estimates by substantial margins. The Jeep represents not just a successful vehicle design, but evidence of industrial maturity that Germany has fundamentally underestimated. Spring 1943. The wind howls across the proving grounds at Kummersdorf, 30 kilometers south of Berlin. Inside the main testing facility, German engineers are discovering truths that will haunt their strategic thinking for the remainder of the war. The American Jeep sits under harsh tungsten lights, its olive-drab paint reflecting the clinical precision of instruments surrounding it. Major Wilhelm Hoffmann circles the vehicle like a surgeon preparing for a complex operation, but what he will uncover defies every principle of German engineering excellence. Franz Müller adjusts the precision measuring calipers in his hands, examining the frame rails with the methodical attention that has made German automotive engineering legendary throughout Europe. The measurements he records violate fundamental assumptions about military vehicle construction. Frame tolerances exceed German standards by margins that would be rejected in any Mercedes-Benz or BMW production facility. Weld quality appears crude compared to the seamless joints characteristic of German craftsmanship. Surface finishes show tool marks and irregularities that German quality control would never permit. Yet the frame demonstrates structural integrity that withstands stress tests, exceeding design specifications by substantial margins. Müller applies hydraulic pressure equivalent to 3 times the vehicle's rated payload capacity. The frame flexes but does not deform permanently. Torsional stress tests simulate the extreme twisting forces encountered when crossing diagonal terrain obstacles. The simple ladder chassis absorbs punishment that would crack more sophisticated German designs constructed with precision tolerances and advanced metallurgy. Dr. Hans Zimmermann focuses his attention on the engine compartment, where the Willys Go Devil L 134 4-cylinder engine presents another puzzle for German technical understanding. The engine block is cast iron, rather than the advanced aluminum alloys German manufacturers employ for weight reduction. Machining tolerances are loose by German standards, with cylinder bore variations that would trigger rejection in Luftwaffe aircraft engine production. The carburetor is a simple single-barrel design lacking the sophisticated fuel metering systems German engineers consider atmospheric operation under varying conditions. Essential for reliable. Zimmermann subjects the engine to systematic evaluation protocols designed to reveal performance limitations and operational boundaries. Temperature tests expose the engine to conditions ranging from -40 degrees Celsius to +60 degrees Celsius, simulating everything from Arctic warfare to desert campaigns. The simple American engine maintains consistent performance across temperature ranges that would challenge German power plants designed with precision clearances and exotic materials. Altitude tests conducted in vacuum chambers simulate high-altitude operations where reduced atmospheric pressure affects engine breathing and carburetor function. The Go Devil engine adapts automatically to changing conditions without the complex mixture adjustments required by German aircraft engines. Dust ingestion tests deliberately contaminate the air intake with fine sand particles that would destroy precision German engines within hours. The American engine continues operating with no measurable performance degradation and minimal internal wear. The transmission presents equally confounding evidence of American design philosophy that prioritizes practical effectiveness over theoretical optimization. The 3-speed manual gearbox employs synchronizers only on second and third gears, a compromise German engineers would consider unacceptable for military applications. The transfer case uses a simple dog-clutch engagement system that German designers would dismiss as primitive compared to their sophisticated constant mesh gear systems. Yet comprehensive testing reveals operational characteristics that exceed German expectations across multiple performance categories. Shift quality remains consistent despite loose manufacturing tolerances that would cause German transmissions to fail within hundreds of operating hours. The transfer case engages reliably under conditions that would damage German four-wheel drive systems designed with precision clearances and exotic lubricants. Components show minimal wear after thousands of test cycles that would require major overhaul of comparable German equipment. The suspension system challenges German assumptions about the relationship between complexity and performance in military vehicle design. Solid front and rear axles connected by simple leaf springs represent technology German automotive engineers consider obsolete for serious military applications. German vehicles employ sophisticated independent suspension systems with precision manufactured components, requiring specialized maintenance procedures and skilled technicians for proper adjustment. The American leaf spring suspension provides ground clearance and articulation that matches German independent systems while requiring no adjustment or specialized maintenance. The solid axles prove virtually indestructible under conditions that would damage German constant velocity joints and precision suspension components. Impact tests using drop hammers to simulate battlefield damage reveal remarkable durability. German suspension components fracture or require realignment after impacts that merely deform American leaf springs without affecting operational capability. By late spring 1943, the accumulated evidence from systematic testing forces German engineers to confront uncomfortable conclusions about American industrial capability and design philosophy. The captured Jeep represents manufacturing principles that contradict everything German engineering education has taught about the relationship between precision and reliability. American factories are producing reliable military equipment using simplified processes that require less skilled labor, cheaper materials, and looser manufacturing tolerances than German industry considers acceptable. The implications extend far beyond automotive engineering into fundamental questions about industrial warfare and national productive capacity. If American manufacturers can build reliable military vehicles using simplified methods and readily available materials, then American industrial output can scale to levels that German precision manufacturing cannot match. The Jeep embodies mass production principles that enable quantity without sacrificing essential quality, a concept that threatens German assumptions about technological superiority through engineering excellence. Intelligence reports arriving from other theaters confirm patterns observed in the Kummersdorf testing program. German forces in Sicily report captured American vehicles continuing to operate reliably despite minimal maintenance and rough handling by untrained German. Units in Italy document Jeeps functioning normally after exposure to conditions that would immobilize German vehicles requiring specialized maintenance procedures and skilled mechanics. The contrast becomes particularly stark when German engineers examine maintenance requirements and operational procedures. American field manuals assume that Jeep operators possess only basic mechanical knowledge comparable to civilian automobile drivers. Maintenance schedules are designed around simple procedures that any soldier can perform using standard tools available in military supply systems. Component replacement requires no specialized fitting or adjustment, with parts manufactured to tolerances that ensure interchangeability across all vehicles of the same model. German military vehicles, trained by contrast, require operators in complex procedures specific to each vehicle type. Maintenance demands skilled mechanics with specialized tools and extensive technical knowledge. Component replacement often requires custom fitting and adjustment to achieve proper operation, reflecting manufacturing processes that prioritize individual precision over systematic standardization. The captured Jeep reveals American industrial maturity that Germany has failed to recognize or appreciate. The vehicle's construction demonstrates manufacturing systems organized around principles of mass production that German industry has never fully implemented despite theoretical understanding of such methods. American factories have achieved production efficiency that enables reliable military equipment to be manufactured by semi-skilled workers using standardized processes and interchangeable components. Testing continues through the summer of 1943 as German engineers document every aspect of American design philosophy embodied in the captured vehicle. They measure fuel consumption rates that exceed German vehicle efficiency, despite the Jeep's superior cross-country mobility. They analyze maintenance requirements that minimize downtime and maximize operational availability, compared to German vehicles requiring constant attention from skilled technicians. The electrical system provides additional evidence of American design priorities that emphasize practical reliability over sophisticated engineering. The 6-volt electrical system uses simple components manufactured to loose tolerances that would cause German electrical systems to fail through unreliable connections and component variations. American generators and regulators operate consistently despite manufacturing variations that would require individual calibration in German electrical equipment. Waterproofing capabilities demonstrate American attention to operational requirements often overlooked in German vehicle design. The Jeep can ford water depths that would flood German vehicle electrical systems and engine compartments. Simple but effective sealing methods protect critical components without requiring complex maintenance procedures or specialized equipment for inspection and service. German engineers begin to understand that they are examining more than a military vehicle. The American Jeep represents an entirely different approach to industrial warfare that prioritizes universal applicability over specialized performance, simplified maintenance over engineering sophistication, and mass production over precision craftsmanship. These principles enable American forces to achieve strategic mobility that German forces cannot match, despite superior individual vehicle performance in specific categories. The captured Jeep becomes a symbol of American industrial philosophy that challenges German assumptions about technological superiority and military effectiveness. German engineers recognize that they are witnessing evidence of manufacturing capability that can produce reliable military equipment in quantities that will overwhelm German production regardless of individual vehicle quality or performance advantages. The autumn of 1943 brings revelations that will reshape German understanding of industrial warfare. As testing continues at Kummersdorf, the accumulated data paints a picture that challenges fundamental assumptions about technological superiority and military effectiveness. Major Hoffman reviews his team's findings with growing unease, recognizing that they have uncovered something far more significant than automotive engineering solutions. The captured Jeep represents manufacturing philosophy that prioritizes universal applicability over specialized excellence. Where German military vehicles are designed for specific roles with Prussian attention to detail, the American machine serves multiple functions with equal competence. Intelligence reports from various theaters document the same vehicle towing artillery, carrying wounded soldiers, serving as a command post, delivering ammunition, and conducting reconnaissance missions. No German vehicle matches this operational versatility. Franz Müller documents maintenance procedures that contradict everything German engineering tradition teaches about proper vehicle care. American field manuals assume that Jeep operators possess only basic mechanical knowledge comparable to civilian automobile drivers. Oil changes require no specialized tools or procedures. Spark plug replacement takes minutes using standard military equipment. Brake adjustments follow simple steps that any soldier can master with minimal training. German military vehicles demand extensive technical knowledge and specialized equipment for routine maintenance. Half-final track drives require precise adjustment by trained mechanics using specialized gauges. Staff car engines need careful carburetor tuning and ignition timing performed by automotive specialists. The complexity ensures superior performance when properly maintained, but creates operational vulnerabilities when skilled technicians are unavailable or killed in combat. Dr. Zimmerman's engine analysis reveals design principles that sacrifice theoretical performance for practical reliability. The Go Devil engine produces modest power compared to advanced German automotive engines, consistent output, but maintains under conditions that would destroy more sophisticated power plants. Compression ratios are conservative, ensuring reliable operation with OCT low-wane fuel available in forward combat areas. Cooling systems are oversized, preventing overheating during sustained operation in extreme climates. The carburetor system demonstrates American design priorities with crystalline clarity. The simple single-barrel unit lacks the sophisticated fuel metering systems German engineers consider essential for optimal performance. Yet the crude American carburetor provides adequate fuel delivery across operating conditions ranging from Arctic cold to desert heat without requiring adjustment or calibration. German carburetors achieve superior fuel economy and power output when properly tuned, but demand constant attention from skilled mechanics with precise familiar adjustment procedures. Electrical system testing provides additional evidence of American manufacturing philosophy that emphasizes practical functionality over engineering elegance. The 6-volt system uses simple components manufactured to tolerances that would cause German electrical equipment to fail through unreliable connections and component variations. Generators produce consistent output despite internal clearances that exceed German precision standards. Voltage regulators maintain stable charging rates using mechanical controls that German designers would consider primitive compared to their sophisticated electronic systems. Yet the American electrical system operates reliably under battlefield conditions that disable German equipment requiring precise calibration and careful maintenance. Water immersion tests demonstrate waterproofing capabilities that protect electrical components during river crossings and operations in wet conditions. Vibration tests simulate connections rough terrain conditions that would disrupt German electrical designed with precision tolerances and delicate adjustment mechanisms. German engineers begin to comprehend the strategic implications of American design philosophy as testing continues through late 1943 and early 1944. The captured Jeep embodies manufacturing principles that enable mass production of reliable military equipment using simplified processes and readily available materials. American factories can produce thousands of vehicles monthly using semi-skilled workers trained in basic assembly procedures rather than master craftsmen with years of specialized experience. When German scientists first tested the American Jeep, they realized the truth about modern warfare. Victory would not belong to the army with the most complex machines, but to the one that could move faster, longer, and farther. The Jeep wasn't just a vehicle. It was the weapon of mobility, and it carried the Allies all the way from the deserts of North Africa to the heart of Berlin.